So, hello and welcome everyone. My name is Karol. I work in Roche as Principal Solution Engineer. I brought some colleagues with me. There is Dan, Marlena, and Alex today with me. So, building medical products is not an easy task. The precision, the reliability, regulatory environments, similarly like building operating systems. For years, the industry has been doing this in a hard way. So we were building custom operating systems for every single device, reinventing the wheel, siloed teams, fragmented hardware. So we looked at this and said, there has to be a better way. You cannot build the future of healthcare on a fragmented foundation. You need a platform. Today, I'm going to share with you what we call one platform and a scale. We call it Roche Linux or just RLX. So, have you ever heard of Roche Linux before? Any of you? So let me explain. So this is not just an operating system. This is Linux distribution for medical products in Roche. I will talk later a little bit about architecture, but you can already see we use Debian as a foundation block for RLX, and the design of RLX is completely modular. We have more than 100 modules and many system flavors. So if you are deploying on physical instruments on-premise, in the cloud, in Kubernetes clusters, or developer environment, it is exactly the same platform. It has been a massive journey in engineering of RLX. Back in 2008, we started origins of RLX. We had a stack running on Windows OS, but as our machines got more advanced, PCR machines like this Cobas 6800 and 8800 and the LC96, we realized that the future is Linux. By 2018, we were bringing in Docker. By 2019, right before COVID changed the world, we migrated systems like Liat from Windows CE straight to Roche Linux. And now, looking at 2025 and 26, we are powering specialized hardware such as SBX, which states sequencing by expansion, or digital pathology, and Kubernetes clusters. You may have heard about SBX device breaking a Guinness record last year. It did that in less than 4 hours. This is just incredible device. So let me tell you my story in how I started in Roche. I joined Roche back in 2019, just before COVID came, and I started from Liat project. And our mission was clear, to migrate from legacy Windows CE to Linux. And Roche Linux has been chosen as operating system. So we had to completely rebuild all the bootloaders, preloaders, kernel drivers, device tree, and so on, and everything for ARM architecture, which we did for the first time with Roche Linux. And we are doing this on 15-year-old device. There was just a single core CPU with just 256 megabytes of memory, and this device was performing PCR tests for influenza A or B, and later also for COVID. So to overcome those constraints and bring that project to market in just a couple of months, it was just a fascinating journey. So where can we use RLX? We can use it from ARM processors like this Colibri IMX6 board and virtual machines to massive data centers and sequencing instruments at global scale. So RLX is everywhere nowadays. The footprint is more than 30,000 Roche instruments using RLX in the field. What are the key features of our system? So it comes with Linux kernel, which can be custom made or hardened. It comes with long-term support from Debian because we base on Debian. It also comes with REST API. unified UI, security features like secure boot, disk encryption with TPM, also integrity check of the system, and this is all seamlessly integrated with Kubernetes cluster and can be also integrated with specialized hardware, FPGAs, GPUs, and so on. So let's look now at typical Roche lab. What do we see? We see entire ecosystem. We see various instruments connected with each other, working together. We have pre-analysis devices, we have analysis devices, and post-analysis devices. And in this environment, everything is regulated. The precision that is needed is absolute. We have a defined network, so every single device has its own IP address. It is a very controlled environment. And inside of many of these devices, acting as a brain, heartbeat, foundation, is Roche Linux. So now let me tell you about the real world. Typical labs look clean and perfect, but the deployment reality is sometimes different, and certain products are installed directly at hospitals, customer infrastructure, or in the customer network. And we call it the on-premise challenge. So imagine deploying critical medical software globally. For instance, in France, they may need ISO installer running on vSphere, or in Argentina, they may need VirtualBox running in Windows. And somewhere else, they are demanding full root access to perform security upgrades. So how do you manage this? You cannot. This complexity is infinite, unless you have a unified platform which can bridge the gap between global requirements and local realities. So to get closer to this platform, an operating system architecture needs to fundamentally shift from the rigid, monolithic, and device-specific builds. It has to embrace highly modular, decoupled, and API-driven design. So let me talk a little bit about architecture. At the foundation, we have RLX running on Debian, but we didn't stop here. We built the RLX OSAL, which is our operating system abstraction layer. It is written in C++, and it handles all the events and procedures communicating via protobuf and 0MQ, now being replaced with gRPC, and we bridged this all the way up from the OSAL Python API to the RabbitMQ bridge up to actual applications which can run in Docker containers, Kubernetes pods, or just natively. And for the users, we have RLX web user interface built in Angular, which is our web frontend, which we will migrate to React soon. And this is communicating via WebSockets and REST API. So you see, this is also completely pluggable. These plugins can be implemented by projects themselves. It is full stack, it is scalable, and it just works. So RLX can come with web-based interface I was talking about. So in here, you can see capabilities like, for instance, system information, where you can change host name, you can change time zone or keyboard layout, and so on. You can do also resource monitoring in real time. You can also change network configuration, manage IP addresses, time synchronization, network settings. You can also do some software management, like software upgrades, like Kubernetes control center, system logs, and so on. This is just an example from one project, but believe me, there is more than that. So to deploy at scale, you cannot just write the code. You have to build an OS factory. So we transitioned from building custom OS images to the platform approach. And to achieve this, We use Molior, we use aptly and Spectra. So aptly is Swiss Army knife for Debian repository management, which basically serves as Debian packages repository. Aptly and Molior are open source projects, with way more contributions from community in aptly. Molior, on the other hand, is primarily developed in Roche. And Molior is not just building Debian packages, it is also used to store information about projects, repositories, mirrors, and so on. And this is all required to be able to create reproducible environment for building Linux distribution. Spectra is a tool which we developed recently in-house, and this helps us to standardize, to catalog OS specifications, features, and also to generate the code and tests that are needed for creating final documentation. So our release workflow is automated. Usually triggers come in. It could be new features, new Debian release, or new security patches from Debian. And the source code lives in GitLab. So we store there all information about RLX packages, deployment configurations, and so on. It flows into our build agents in Molior, and then it is packaged into aptly and deployed later to GitLab dedicated runners or our own runners, and then we store the artifacts in Artifactory. So in the end, our final deliverable is one RLX version. For example, we are now releasing version 2026.3 because it's March. So let's briefly talk about the RLX lifecycle and infrastructure. Because a platform is only as good as its ability to survive and adapt in the real world, how does a new version come to life? It always starts with a trigger. So the new version is usually triggered by a project request, Debian or security update. And then we enter into development phase, which leads to the production phase, and finally the product needs to be serviced for a certain time in the field. From the infrastructure perspective, we build a collection of RLX components in the form of Debian packages, which we deploy into specific types such as Docker or ISO installer. Then we test, document, and deliver them to the market. And the device in the market usually needs remote access. It needs field service representatives secure login. It has to be capable of upgrading. And usually the lifetime of these instruments is like 10 years or more. I know this is quite a lot of information, so let's quickly go to the point. So what is the vision behind RLX? We are providing end-to-end secure and reliable Linux solutions that cover the whole development and product lifecycle of Roche products. So we removed the hurdles. We deliver, or try to deliver, high-quality, customizable OS configurations so developers can onboard rapidly. We embrace the power of co-creation and collaboration. We provide end-to-end OS delivery from the first check-in to the last update. And it all comes with fully automated documentation, is validation ready, has to be at any time, and always according to the workflow, which is design, develop, release, and update. So now let's look at the people on this screen. This is not an army of thousands. Nowadays, exactly 13 people are working on RLX and making Roche Linux happen. So we are based in Rotkreuz. This team manages currently 30 projects and ships 40 major releases a year. At the end of the day, all this technology, all these containers, and all these packages, it is all in service of one vision. We are doing now what patients need next. Thank you.
Are there any questions for Karol? Then we have a micro here.
Do you do any kernel developing, or you just it's the main kernel from upstream?
The kernel.
Do you do
that we
any
use.
driver?
Sometimes it happens we have to do some drivers, but it's very rare, to be honest.
So it's just the upstream kernel, you don't do anything else?
Usually we try to use upstream kernel, I mean from Debian, which is patched by Debian, but in most of the projects we need to go through the hardening phase and customization. So we minimize the kernel, we harden specific things in the kernel.
Just configuration, it's not any code changes.
You know, when we do hardening or we recompile, sometimes we have to do a little bit of changes in the kernel, to be honest, because we package in our way. We don't use Debian packaging.
You just answered my question. You don't use Debian packages. You don't use deb, aptly. You use aptly. So.
Yes, we do.
So my question is, how do you ensure immutability? How do you ensure immutability? How do you test end-to-end and ensure that what's deployed in the end is actually what you tested? Because for me, it's the biggest problem I have with Debian. I can't ensure that.
Do you mean how do we know what we installed is what we expected to be there, right?
Yes, exactly, so, to the bit.
Yes. That's a hard question. I mean, we use mirrors, right? We have aptly, we have Molior, we can create mirrors, and we know what we have on the mirrors.
Mm-hmm.
So we know what we pull from, right? But if you build ISO installer, right, it's not always deterministic, right? There can be some bits changed if you rebuild the same ISO, right? So we are trying to test on what we built, what we delivered, right? We don't rebuild that later, usually. When it's released, then it's released, it's ready.
And you update using apt update, apt get update? Or?
In the end, we built our own upgrade packages. We have our own mechanism to upgrade. So these are signed packages using in-house code signing mechanism with signature, which is Roche signature, specific for the project. We have our own mechanism to upgrade Kubernetes, so we can jump like 10 or more versions up if it's needed.
Okay.
Any other questions?
Sorry, I can ask, is this open source? Like anybody can, or is it like licensed?
The license.
Is this licensed? Can I like purchase a license for your?
I don't think so. You would need to come to Roche to play with this.
Okay, so this is it's not open source. It's for your client.
The open source part is just Molior and aptly, so feel free to use. I would be very pleased if we have more users, especially for Molior.
Okay, then let's say thank you again for Karol and